There is an undiscovered planet in our solar system. Somewhere on the distant edge, so far from the Earth that it can't be seen, lies a mystery that scientists have been chasing for 100 years. This is Planet 9, a solid ball of ice and rock. It's at least double the size of Earth and maybe up to 6 times heavier. Planet 9 orbits the Sun at a distance way further out than Neptune and Pluto, reaching up to 500 times the distance from the Earth to the Sun. And it's actually tilted at an angle about 16 degrees off from every other planet. The orbit is so long that it would take Planet 9 up to 15,000 years just to complete one cycle. Out here, even a very large object would be almost impossible to detect. We've been fooled into thinking that we already know everything about our own solar system, but the truth is that we've only just scratched the surface. Now you might be wondering, if we can't see something, then how do we know it's there? This is a fair question, and it's actually a big part of the scientific method behind some of our most important astronomical discoveries. It all begins with Uranus. The 7th planet from the Sun was first discovered by a guy named William Herschel in the year 1781 using a homemade telescope in his backyard. He wasn't looking for new planets, he was actually looking for comets, and that's what he thought Uranus was at first, until it turned out to be something much bigger. That's one way to discover a new planet, by accident, but this is not exactly a repeatable method. Now, Herschel wasn't the first person to see Uranus. It had been appearing on star charts for decades at this point. It was just so faint and moving so slowly that no one had really noticed it before. But as scientists continued to track the orbit of Uranus, they started to notice that it was behaving in a very strange way. At certain points along its path, the planet would speed up or slow down, almost as if something was pulling on it. The technical term for this is a perturbation. It basically means that objects in space do not just do weird stuff all on their own. Some external force influences them to do it. So, what is perturbing Uranus? To find out, we move ahead to the year 1846. A pair of astronomers named Urbain Le Verrier and John Couch Adams determined that there must be an undiscovered planet in the outer solar system that is responsible for the odd behavior of Uranus. And they used the science of orbital mechanics and good old-fashioned math to calculate exactly where that mystery planet must be located. So, over in Germany, another astronomer named Johann Galle decided to point his telescope right where this new planet was predicted to be, and within just a few hours of looking for it, he spots Neptune, the 8th planet from the Sun, for the first time. Once that discovery was made, people got the idea that using math was a much better way to find new planets than just randomly pointing a telescope and hoping to see something important. They started looking for more odd perturbations, and they found one. Actually, in the orbit of Neptune, it appeared to have a little bit of a wobble to it, so the hunt was on for Planet 9. And that is how we end up in the year 1930 with the discovery of Pluto, the object formerly known as the 9th planet from the Sun. This is where we should probably introduce a term known as observational bias. They went looking for a new planet beyond Neptune. They found something, therefore it must be the planet in question. It wasn't though. Pluto is a highly reflective object, so it appears big and bright through a powerful telescope, but it's actually very small and wouldn't be anywhere near massive enough to influence the orbit of Neptune, which actually didn't have a wobble after all. That was just an error in measurement. But that did not stop the hunt for new planets. It just meant that astronomers would have to work a lot harder to try and find one. And that's where we are at right now. In the last 3 decades, there has been a flood of new discoveries made in the deep solar system, a region that we know as the Kuiper Belt. This is where Pluto is located, but it's also home to an incredibly large amount of other ice and rock structures. For a sense of scale here, there are probably thousands of Pluto-sized objects in the Kuiper Belt. We've identified a handful of them, but most are still undiscovered. And then there are at least 100 billion other objects out there that measure at least 1 kilometer across. Now, the location of our suspected Planet 9 is far beyond the Kuiper Belt, but if it is out there, then we should be able to see the effect of the massive planet's gravity on distant Kuiper Belt objects. And that is exactly what 2 astronomers at the California Institute of Technology believe that they discovered in 2016. Mike Brown and Konstantin Batygin noticed a weird cluster of objects on the outer edge of the Kuiper Belt. They were all grouped together in this long, tilted orbit that didn't appear at all like a bunch of random stuff spinning around the sun. It looked like some external force had been guiding these objects into a very specific alignment. And the more Kuiper Belt objects that are found, the more of these strange behaviors the astronomers began to notice. They found things that would orbit over and under the sun instead of around the middle, things that would move in the opposite direction to every other orbiting body. And just like back in the day with the discovery of Neptune, these scientists have calculated that there must be one large source for all of this strange behavior. To do this, they used a computer simulation. It started with the solar system in a raw, chaotic state, as it would have been back when the planets had newly formed. Then they presented that early solar system with 2 potential scenarios. One includes Planet 9, and one does not. Turns out, when Planet 9 is included in the simulation, all of the distant objects of the Kuiper Belt line up exactly with what we see today in the real solar system. So according to that study, there is something like a 99.6% certainty that Planet 9 does exist. Now, one thing that this simulation doesn't address is just how we ended up with one big planet stranded so far away from the sun. The whole reason that the Kuiper Belt exists is because there wasn't enough density out here to form a whole planet. This means that Planet 9 must have come from somewhere else, and that somewhere could be an entirely different solar system. This is what we call a rogue planet. It's a body that was ejected from its home star and ends up just floating through space. The gravity of our sun may have captured one of these rogues at some point billions of years ago. It's also possible that Planet 9 used to be much closer to the sun and began forming somewhere between Saturn and Neptune, but was kicked out before it had the chance to become another gas giant. It wasn't kicked hard enough to go rogue, so it just ended up stuck on the very edge of the sun's gravity. In either case, Planet 9 itself would be an incredibly dense ball of rock, metal, and frozen material, like the core of a planet that never got the chance to fully form. If you can imagine something being even more dead and frozen than Pluto, this would be it. Now, for a planet that no one's seen before, we seem to know a lot about this thing, but where is it then? Unfortunately, finding Planet 9 is not going to be like finding Neptune, which is already a really hard planet to see. But the thing we are looking for could be more than 15 times further away than Neptune, and it would be smaller as well, and less reflective because it doesn't have a vibrant, gas-filled atmosphere. It's very likely that Planet 9 would be invisible to everything but the largest telescopes on Earth. And even with those telescopes, this is still a needle in a haystack situation. Unless, of course, Planet 9 doesn't actually exist. Remember when we talked about observational bias? The Caltech astronomers Brown and Batygin have been looking specifically for evidence of Planet 9, so naturally, that's what they found. But could there be other explanations? Absolutely. One of those potential scenarios is even more insane than a mystery planet. Some people think that there might be a very small black hole moving through our solar system, and its immense gravity is messing with orbits. This would be something known as a primordial black hole. It's theorized to have formed right after the Big Bang, at the very beginning of the universe, when dense pockets of matter started forming into the first stars. It's possible that the most dense regions actually skipped the star phase and collapsed straight into black holes, and they've been touring around the universe ever since. If these even exist, we probably don't have one in our solar system, but just like Planet 9, the theory hasn't been proven wrong or right. A more simple explanation would be that gravity just works a little differently at large distances from the sun. And something that looks weird to us is actually just nature doing its thing. All of the predictions that we make about gravity and orbits are still governed by the laws that were laid down by Sir Isaac Newton in the 17th century. But Newton had never seen anything that was further away from the sun than the planet Saturn, so it's possible he missed some stuff. We fool ourselves into thinking we know everything about the solar system just because we can see a lot of things that are close to us, but the more we discover in the outer reaches, the more we know we don't know. But we will know a lot more very soon. This is the Vera Rubin Observatory. It is the most technologically advanced telescope on Earth. It has the biggest and highest resolution digital camera ever made, and it's attached to a motorized system that allows the telescope to capture an image of the entire visible night sky once every 3 days. Vera Rubin started operation for the first time in the summer of 2025, and its goal is to continue making these super high resolution scans of the night sky over and over again for the next 10 years. So what we will end up with is a time-lapse video of everything in space. And as we create that video, we won't need to go looking for weird objects anymore. They'll make their own presence known in these observations. So we will definitely find things like new comets, interstellar objects, near-Earth asteroids, and if there's a 9th planet out there, then we'll find that too.